So what we have tried to do, as a systems and security group at IIT Gandhinagar, I would basically briefly introduce the faculty here and what kind of problems we are working and what are the projects ongoing. And I also request Dr. Abhishek, who is also part of the systems and security group, to talk on some specifics of the work that he's doing. Okay, so I'll try to, we'll split it in two halves. Okay, so first, I would like to introduce the faculty here, and Professor Abhishek Bichhawat is one of the core members of the Systems and Security Group. And I think you would have already seen the faculty profiles, and I will not have to talk much here. And so currently, what we are trying to do together is also look at some of the systems and security areas. And in this case, basically, we would like to mention about the key research areas. And first, as a systems and security, I would like you all to know, what is it that it means as a systems group? So you learned about theory, what kind of problems have been tackled, and what are the ways that you can come up with solutions. But somewhere you need to deploy them and make them practical, right? And that's where the systems and security groups meet. And you will hear more from Professor Nipun on the systems applications. And the core of the systems, what we are going to do is what I'll try briefly mention about, okay? So when we mean systems and security group, there are basically the characteristics of a system and characteristics of how we want to build a system are what constitute about what we are trying to do research here. And some of them seem like, okay, it's an engineering, but it's more of an engineering and research put together. And that's the perspective that we need to build here, okay? So when we think of systems, we think of basically we have a system we need to manage. As networks, we manage quite a lot of things of how the data has to move, what are the ways that you want to build the connectivity, all of them. And that's where the backbone of it would be some theory, but you would have to materialize that as some aspect. And that's where the management and orchestration of specific things, especially when we talk about data center networks, and when we talk about the clouds, all of them. And these become the key aspects to look for how we can do the management and orchestration of different systems. So which include basically how you provision the resources, how do you want to control making the systems, automation of specific aspects, how do you want to manage the traffic, and so on. Okay, so this basically would be the first imprint of what systems engineers or system researchers would be trying to do. Next up, when we want to build a system, you're always want to make the systems more efficient. And when we want to quantify the efficiency, or think about either the performance or the power aspects. So here, typically, you are more concerned about, given a system, how is it behaving, what's the performance it's providing, and how would you want to improve the performance of such a system, what's the power overheads that it has, and how do you want to minimize those aspects. And these come in different flavors. And you can think of these as trying to basically provide a means to have better resource utilization, which would automatically mean that you are trying to improve the performance of a system. And in doing so, you may have different aspects to look for, how are you scheduling different workloads, what are the units that you need to schedule, all of these. And when you have multiple instances to deal with, how do you balance the load across different instances? And how do you ensure that all the systems are behaving uniformly and in a necessary fashion, right? So the load balancing as one of the key aspects. So when we think of systems and think of systems performance and power aspects, we deal with these many different kinds of areas. And next up, when you have a system, you don't want a system that goes down, right? So you want to ensure that the systems are more robust, built for ensuring that they're available all the time that you need them. And systems also need to behave in a way that you would want them to behave, right? So availability and reliability aspects of a system that you want to build become the crux of ensuring that the things work as expected. So for this, we need to look at what are the means to build the fault. If there are faults that can occur, then you need to tolerate such faults, right? So how do you build a system that is fault tolerant? And how do you ensure mechanisms that are going to ensure that the systems work, even in the case of failures? Ensuring these aspects become another core area of what the systems group looks at. And once we have a system that is good enough, that is available as you need, and it is reliably working, you also need a new aspect to look at in a very core dimension, and that's security and verification of the devices. Because if there is a device and that becomes a vulnerable point, you may lose a lot of information. So you want to ensure that the system that you build is secure enough. And this security aspect comes in several facets, like depending on the kind of a system, it could even start with the hinge of protocols that you want to build, how many users you want to support, what are the policies that you want to build around in accessing such devices, all of these aspects. And security and verification also become an integral part of when we want to make the systems research together here. Okay, so we'll have Professor Abhishek speak on the specific aspects of security at a later point, but I'm just trying to give a nutshell overview of all the aspects. Okay, so once you have these kind of systems, and the most fundamental thing then becomes is like we have this heterogeneous world and we have so many things to deal with. And if one system cannot talk to other, we have a problem, right? So we also need to look at the dimension of how we want to bring up this interoperability among different systems that we want to build. That means you need some standardized schemes and APIs that you want to build, and also have the portability across different models and platforms. So that means you need to have right protocols in place that would enable you to build the systems that are portable, right? So these basically cover, like I tried to put the dimensions of what the systems and security focuses would be, okay? So I hope you get the brief overview of what we mean in systems and security group here. And like, like we are in the digital era and there are a lot of possibilities, and the work that you can think of, any systems that you want to realize, any system that you want to build becomes a part of like one of these umbrellas to look for. And that's where the systems group caters to work on. Okay, so in building up your interests towards these areas, we also have basically specific courses, and what you look, some of the undergraduate courses that you would have already taken, and what we need as a systems research or systems engineers to work on as the fundamentals in these courses to be vital in this. Okay, so we have the structure of courses that are taken up here at IIT GN and at the undergrad as well as the PG level courses that would help you build on it. So I see Eugen, you have raised your hand. Is there any question? Okay, so let me continue from here. So typically, like, yeah, these are some of the systems courses that you would be taking up here as your journey in the systems area. So there are several key research areas. So we cannot get into the details of each of them, but just to give you a glimpse of what's the state of the art and where we are looking for, try to break up as basically like when you look at the networks as a core areas, now we are wanting network as a software rather than network as a system that you would want to work with as a hardware and a ossified pipe. So think of network as a software, and that means networks become more programmable. So when you look at the programmable networks, then you want to see how we want to build the platforms. And here at IIT Gandhinagar, we are trying to look at building high performance NFV platforms. And here we are trying to utilize smart NICs and programmable switches, which can enable you to build the programmable or make the networks more softwareized. Okay, and in terms of the areas that hinge on this programmable networks is how you want to utilize building the systems. Like when you want to build any security devices, how would you want to define them, design the protocols so that they can communicate? And that's where we are looking at the means of using the serverless computing as a model, where you want to build the individual functions that would just operate and do one unit at a time. And in doing so, what are the models that you want to build and how you want to express those functions, and what are the ways that you want to develop the jobs that can be run on those functions. become a core area to look at. Okay, and we also have other areas like AI, ML, Edge, 5G, and IoT areas. I think some of them will be covered later, and all the cybersecurity aspect, which is now one of the major areas to look for. When I said you want to build the systems and the protocols and algorithms and ensure that you are building a secure networking infrastructure. And that's where much of the focus of cybersecurity area hinges on. And we have some of the ongoing projects here in terms of networking systems. We are building a smart network intelligence platform. And we are also looking at building the security area for the telecommunication networks in terms of how you build the IPDR logs and aspects. And in terms of principles and protocols, which is also an essential aspect to say, when you want to operationalize some system, you want to see what are the underlying ethical frameworks that are governing them. And how do you want to ensure that these ethical frameworks can be evolved over time? So these are some of the ongoing projects right now in the systems group. And we also have a lot of areas to explore besides what we have in terms of, when I said serverless computing and how you want to architect the future cloud solutions, you would be more keen on saying, okay, how, if you look at the era of cloud computing, how it has evolved. And when we talk about the serverless, which is of the last 5 years that we are looking at how the cloud should be re-architected, that opens up a lot of areas to look for in terms of how you want to schedule the jobs, how you want to offload some features and ensure reliability still at the cloud the way we have in the current distributed system. So all of these aspects also need a future thought on making these areas work as we expect. Okay, so I'll skip upon the other project details, but I think I have given a brief overview of like what's going on in the systems and security group, and more details on basically the projects that we are looking for in terms of security when we want to build the next generation security solutions for networking and monitoring for the telecommunication operators, is to look at how you explore the programmability of the switches, enhance the programmability, and build the monitoring platforms. And so these are some of the core works that are ongoing. And we would like to see why you need security and what are the aspects of security that you need to be looking in. And I would basically ask Professor Abhishek to continue from here.
Thanks, Samir. Good evening, everyone. Right. So let's say I wanted you to design an application to sell rubber ducks. So we want to sell rubber ducks to people, and you want to design an application, a website that needs to do that for you. It's like an e-commerce website, but does much more interesting stuff. It's selling rubber ducks. Right. So suppose you want to build an application that has to sell this rubber ducks online. How will you go about it? Right. So the first thing you do is to write an HTML page, a proper website sort of, that displays the available types of ducks, providing various functions like logging in, saving items in the cart, purchasing items, etc. Right. And then you can ask the user to sign up on your website with their personal details. You store their name, email, password, etc. You ask the user to sign up on the website with their personal details, name, password, etc. And then the user selects the ducks they like. And once they've done that, you're going to ask their credit card numbers, the bank account details to pay for the ducks and send the order. What you may also do is to store the credit card numbers or the bank account details for post-payment verification. So most of the times the verification happens later on. Or if you want to refund the user, let's say the user does not want the duck, he has too many ducks. So you may want to refund the user because he's returning the item. And so you need the details for that as well. Finally, you thank the user for coming to your website, right? But an important thing to note here is that your application is storing lots of secret and private information. Right? So we're storing the name, address, email address, the password, and the credit card details, the bank account details, and so on about every customer that comes into the system. So what if an attacker can break into your application? What if an attacker breaks into your application? What would happen? Will the attacker be able to get access to all of these? Will the attacker be able to get access to all of the private data that is stored on the system? And the answer to that is yes. Right? So the only way to do that, the only way to prevent that is to basically have security in the system, right? And security has been defined in various ways over the years. So Ross Anderson, one of our security experts, has just defined security as basically building systems that remain dependable in the face of malicious, error, or mischance, right? Palo Alto Networks, on the other hand, has defined security as a set of techniques that are used to protect the integrity of an organization's architecture and safeguard its data against attack, damage, or unauthorized access. Right? So overall, we want to prevent the illegal or illicit access of data or information by adversaries or anyone, for that matter, given an application that we designed. Right? So why do we care about security? So it is possible that my application will never be broken into, so I don't care about the security of that application. Right? But a rule of thumb is basically that everything can be compromised. Right? So everything that exists on the internet today can be compromised. Right? So as applications get attached to the internet, the possibility of the attacks increase manifold. And a very, very beautiful example of this is this casino that got hacked through a fish tank thermometer. Right? So there was a thermometer in the fish tank. You would never think that a thermometer in a fish tank would help the adversaries actually get access to the casino and siphon off millions of rupees. Right? So we do need to care about security of systems. We do need to care about how these systems take security into account when they are built. Right? So the big idea here is basically to secure how this data is stored, transferred, and accessed. Right? So the data from the time it's generated to the time it is used and to the time it's sent over the network should be secure in some way or the other. There are various ways to do that. And the two very important ways, or the two very common ways to do that, are to use cryptography and access control, which is a major part of security, which is a major part of how security is built. It's a cryptography, as you might be knowing, is one of the most well-known techniques for securing data. And they use basically encryption. They have some secret keys which help you encrypt the data. It's like locking the data with a key and then unlocking it using the same key or some other key, which is like a master key, which can unlock the data. Right? Access control, on the other hand, is going to define who is authorized to access what data and what the user can do with that data. So if we have these mechanisms in place, we can secure the data that we have access to and that we have stored in our systems. At IIT Gandhinagar, what we work on are similar areas. We do not design cryptographic algorithms. They are very difficult to design, but we do not design those algorithms. Instead, we verify protocols that are built using these algorithms. Right? So there are various cryptographic algorithms, and there are various protocols that use these cryptographic algorithms. Take, for instance, WhatsApp. You all must be using WhatsApp on a day-to-day basis. WhatsApp uses some sort of encryption. When you open the chat box, when you open the chat page, you can see that WhatsApp tells you that these messages are encrypted end-to-end, right? So it uses some crypto protocols to guarantee that this end-to-end encryption happens. There's no one on the network who's going to be able to read that. But how do you know that WhatsApp has implemented it correctly? How do you know that the messages will not be leaked to a third party? And this is what we work on here at IIT Gandhinagar. So we have built a framework which is going to help us verify these protocols that have been written, which these real-world applications use, and we can derive implementations, some reference implementations out of these verified models, which can then be used by applications. The other aspect of the research, which we do here at IIT Gandhinagar, is about a very specific type of access control, which is information flow control. The idea is that we are doing fine-grained access control, wherein we are going to secure how the data flows through an application. So even if you have access to the data, you should only be able to do controlled number of things with that data. In particular, we work with security of the browsers in browsers when data is accessed by a browser and used by an application like a website or a third-party script on the browser, and how this data is flowing across the various elements of the browser. So this is a high-level overview of what research we do at IIT Gandhinagar. And there are many other aspects of security that we can work on, and we continue to work on, which you might be having good knowledge of. So with this, I conclude our presentation. If there are any questions, you may ask us now, or you can email us at these email addresses.